Welcome to the today's video lecture series. In last class, we were discussed about the permanent magnet brushless DC motor, about its construction, operation, speed, torque, characteristics. In today's session, we are going to discuss about the AC motor, that is the induction type motor. So which comes under the course outcome 3 to exemplify the electric propulsion system and motor controlling techniques, under which the learning outcome 3 is to discuss about the electric propulsion system, under which the specific outcome 2 is to explain the construction and working of an AC motor, that is an induction type motor. The content of the today's presentation has been associated with construction of induction motor, stator, rotor, and the types of motors and the types of rotors in the induction motors. So let us go into the topic now. So we know that the important parts of the three-phase induction motor have been specified in the schematic diagram. So the three-phase induction motor are classified into the two parts broadly. First one is the stationary part, which is called as a stator, and second one is the rotating part, which is known as the rotor. These rotating parts are supported by means of the bearings. The stator and rotor are made up of the electric circuits, and they are usually made up of the insulated copper or aluminium in order to carry the current, which forms an magnetic circuit, which are usually made up of the laminated steel to carry the magnetic flux lines, which is an imaginary lines. Next, so this is an constructional diagram of the three-phase induction motor. So this is said to be the stator slot. Inside the stator slot, the stator coils or the stator windings have been placed. The stator slot act as a house for the stator conductors to be placed inside it. So this is said to be the stator lamination. So this laminating materials are usually made up of some steels in order to avoid the eddy current loss and the hysteresis loss due to the magnetic material. Next, this is said to be the rotor. So this is said to be the rotor slot. So this rotor slots are used to place the rotor conductors. Hence, this rotor slot is acting as a house for placing the rotor conductor within it. So this is said to be the rotor lamination. As I told, for the stator lamination, these laminations are used to avoid the eddy current and hysteresis losses. And this is said to be the air gap between the stator and the rotor. So in this air gap only some magnetic flux lines will be wasted during its operation. So this is said to be the shaft, which is associated with rotor part of the three-phase induction motor. The shaft is used to connect with the mechanical load in order to run the mechanical load successfully. Next. So the stator frame is said to be the outermost part or outermost cover of the three-phase induction motor. Its main function is to support the stator core and the field windings. So it is acting as the stator frame is acting as a covering, and it provides as it is acting as a covering or outermost part, it provides the protection and the mechanical support and mechanical strength to all the inner parts of the three-phase induction motor. This stator frame, that is outermost part, is like a cylindrical core which has been made up of the thin lamination of the silicon steel in order to reduce the hysteresis and the eddy current loss. This hysteresis and eddy current loss are due to the magnetic formed circuits it occurs. Next. A set number of slots are provided on the periphery, that is the outer side. So these slots, stator slots, are used to carry the stator conductors inside it, or the stator slots are acting as a house for holding the conductors, stator conductors within it. So the insulated conductors are placed inside the stator slots and they are suitably connected to form the three-phased balanced star circuit or a delta connected circuit. So if it is a star circuit means there will be the neutral point. If it is a delta connected circuit means there won't be any neutral point at all. It is a direct short circuited circuit in the terms of the delta fashion. When three-phase supply is given to the stator winding, we know that in the stator winding, after the three-phase supply is applied, it forms a rotating magnetic field. So this rotating magnetic field induces a current in the rotor according to the Faraday's law of electromagnetic induction. Next, so the rotor, this rotor part is another part of the motor. This rotor is placed inside the stator. The rotor core is also laminated in construction in order to avoid the eddy current and the hysteresis loss. So this rotor core is also cylindrical shape, which is also having the slot as seen in the diagram on its periphery in order to carry the rotor conductors within it, or in order to hold the rotor conductor within it. The rotor conductors or winding is placed in the rotor slot as I told earlier. The rotor of three-phase induction motor can be either two types. First one is a slip ring type induction motor, which is also known as a wound rotor induction motor. Second one is a squirrel cage type induction rotor. So first we will see about the slip ring type rotor. This slip ring type rotor are also known as the wound rotors. This type of rotor is provided with a three-phase star or delta connected circuit in which the windings are wound on for the same number of poles as like as the stator. The rotor core here also made up of the steel laminating material which have a slots in order to accommodate the three single phase windings. So these windings are placed 120-degree electrically. That means these windings are 120-degree electrically separated. These three stator windings are stand internally, and other end of the three windings are brought out and connected to the slip rings, and the slip rings are mounted on the rotor shaft. So the three terminal end touches these slip rings with help of the carbon brushes. So this carbon brushes will be against to that of the slip rings, so which are held against to the slip rings with help of the spring assembly. So consequently, this type of motor is often referred as a slip ring induction motor. So this diagram helps to understand about the slip ring rotors. The slip ring windings are connected in the rotor windings are connected in the star connected fashions. So each end of the windings are connected to the slip rings with help of the brushes. These brushes, carbon brushes, are against to the slip rings. These slip rings are mounted on the shaft to which only the mechanical load have been connected or coupled in order to run the mechanical load successfully. The end of the brushes are connected with the resistors. So these resistors are said to be the external resistors, and also it is said to be the variable resistors. By varying these resistors, the rotor torque can be controlled and also the rotor speed can be controlled. Next type of rotor is a squirrel cage type rotor. The motor which is having this type of rotor is said to be the squirrel cage induction motor. It consists of a laminated cylindrical core having a parallel slots on its outer periphery, outside. So one copper or aluminum bar is placed in the each slot. All these bars, copper or aluminum bars, are joined at each end by the metal ring called as a end ring, which will be showing in the figure. This forms a permanently short-circuited windings. The entire construction, that is, bars and the end rings, will resembles a squirrel gauge induction motor. So the squirrel gauge induction motor main drawback, it has a low starting torque only, whereas in the slip ring induction rotor it has a high starting torque. Next, in squirrel gauge induction motor, it is because the rotor bars are permanently short circuited and it is not possible to add any external circuit to the rotor circuit to have the large starting torque. So that means this squirrel gauge rotor will not have a high starting torque as like as a squirrel slip ring. So this is the induction type, squirrel gauge induction type rotor. So this is said to be the shaft. The shaft is used to couple with the mechanical load in order to run the mechanical load effectively. And this is said to be the fan blades. And this portion is said to be the iron core which has been laminated. This iron core has been laminated in order to avoid the eddy current loss and the hysteresis loss due to the magnetic effect. And this white color is said to be the aluminum bar, or sometimes we can make use of the copper bar also. This aluminum bar or the copper bar, whichever it has been used in the squirrel gauge type rotor, so it is used to connect the coppers, I mean the rotor conductors, which have been placed in the rotor slots. So this is what about the idea of the construction parts of the three-phase induction motor. So I hope that you would be understood. Thank you.